What are collinear points? The word collinear has derived from a Latin word call linear. Call means together, and we know linear is a straight line. And points simply mean points. So the definition of collinear points is as follows: three or more points lie on a same straight line. So visually we are going to have a straight line, and we are going to have 3 points A1, A2 and A3, and we can call A1, A2, A3 are the 3 collinear points because they all lie on the same straight line. Now there are many ways to prove that the 3 points are collinear in geometry. So we are going to see each method. The first method we are going to see is the area of triangle. So the area of triangle is equal to 0, implies that the 3 points are collinear. We are going to understand why area of the triangle becomes 0 when 3 points are collinear. So let us consider the triangle delta 1, which is the triangle ABC, and we'll say the area of this triangle to be, for an example, it is 20 square units. Now if I bring down the point C to C1, as we know the altitude of the triangle gets decreased, thereby the area of the triangle gets reduced. So the area of the triangle ABC now is any value but lower than 20, let's say it to be 15 square units. Similarly, when I bring down the value C to C1 to C2 now, the area of the triangle ABC2 would be now around 7 square units. These are just random numbers. Now if I bring C2 to C3, the area of the triangle ABC3 is going to become around 3 square units. So it is quite evident that when the vertex C gets lower and lower, the area of the triangle gets reduced, and at one point it is going to fall on the line segment AB itself, so which is the triangle ABC4. Now this triangle has no height, it has base but no height, so the area of the triangle becomes 0. So can I call ABC4 to be a triangle? Yes, but not exactly. We can call them to be a degenerate triangle. A triangle which has no height can be called as a degenerate triangle. So collinear points are actually a special case of triangle. They are a degenerate triangle, and that is why area of the triangle is 0 when 3 points are collinear. And method 2 are slopes. Using slopes, one can prove that the 3 points are collinear. So let me just draw a straight line with 3 points A, B and then C. Now let me focus on the point slope of AB. Slope of AB meaning we are going to find this particular line's slope. Slope is the inclination with the x-axis. So how inclined the line is what slope is about. So slope of AB is A, and if I take slope of BC, slope of BC is also going to be A. Why? Because the line AB and the line BC both of these lines are parallel to each other. Parallel in the sense they are going in the same direction. They have the same inclination. If you think about it, they are going to have the same inclination. So these lines are said to be parallel to each other. So slope of AB is equal to slope of BC implies both the lines are parallel. But there is also another hint in the above equation. B is the point that is common to both, which means these two lines are not the usual parallel lines that never meet each other, but rather we are going to have it like AB and BC. If B is a common point, B can't be in two different places, as B is a coordinate, it should be in one place. So B has to be not something like this, but something like this, AB and then C. So it means that AB and BC are parallel to each other, and B is a common point which brings both the line segments together, and thus we can say that A, B, C are collinear now. This is another way to prove that the 3 points are collinear. This is your third method. This is using your distance formula. This is quite easy. Let me have 3 points A, B and then C. Let me have 3 points A, B and C. So distance from A to B plus the distance from B to C has to be equal to the distance from A to C. Then I can say that the 3 points are collinear. Here A, B, C are collinear. So this is also actually a form of a triangle inequality. It's also a special case of your triangle inequality. Your triangle inequality states that sum of lengths of two sides of the triangle is always greater than your third side. Only then it can be considered as a triangle. But here we are saying A plus B is equal to C. Meaning, let me construct a triangle. So let this be A and let this be C, B and this be C. Now can A plus B be equal to C? No, definitely not for a triangle. But when it is a collinear point, this point, as I already mentioned, is going to be on the base. So now we are going to have the point over here. So the A distance would be this and B distance would be this and the C distance would be this. So here we are having A plus B is equal to C. Now the triangle inequality has been destroyed. Why it got destroyed? Because it is no longer a triangle, it has now degenerated into a straight line. So these are the 3 methods of proving 3 points to be collinear. So let me know in the comment section which technique you like the most to prove the points are collinear. Thank you.